topics again. All right, I'm going to keep continuing going over these. My goal today, all SOHCAHTOA. All right, all SOHCAHTOA. All right, so again, Hill, SAS, 30, 60, 90, 45, 45. We won't review the Monday and Tuesday we get back. I'm going to keep continuing. Monday, I'll actually finish this, and then Tuesday is your work day. All right, Tuesday's fully your day to do whatever you think you need to do, and then on Wednesday, is the test. All set? All good? Okay, before we end 30, 60, 90, 45, 45, I mentioned in class I wanted you to do a group problem together. All right, that involved the 30, 60, 90, and a 45, 45, 90. So if you get to go to your packet, and it's practice question number 1 out of your packet. Before I leave you to go on your own, let's quickly review properties of a rhombus that will probably help you out in this problem. You're going to start talking, because I need to know the lengths of the diagonals. So tell me something about the diagonals of a rhombus. Addie. They're perpendicular to each other. They bisect each other. And there's one other one I think will help you out here. They also, yep, Via?
The angles opposite from each other. Oh, no. Oh, wait, sorry. All sides are congruent.
All sides congruent. I'm looking one more for the diagonals.
Oh.
Diagonals bisect each other, and the angles they're drawn to, they bisect. All right? So let's get going there. Also, notice my directions say simplest radical form. I don't want you to use sine, cosine, tangent. I want you to use your 30, 60, 90, 45, 45 rules, please. All right? I need it in simplest radical form. Let's get going. You can talk it over with your group. This is a big group problem here. Not the easiest. Got to go back to your rules. Good now?
Yeah.
Sure.
Can you,
Yep, what do you need?
Where to go?
60.
English.
Oh, yeah.
So AC is.
Yeah, because it's constant.
No.
It's 30. Hold up.
Yeah, that's 30.
Right. Yeah, that's what, yeah. Okay. So what are we doing? 60. Oh, this is 30, 60. 30, 60. Okay. Oh, that's easy. It's just.
Oh, you're trying to find
Hypotenuse is the electrons. So,
Oh,
because
so
I'm the solar,
D,
it's
B,
D10 equals
B,
2
D.
times.
B,
Oh, yeah, because.
AC is. Yeah.
So
So the D equals 10. And just find the longer leg. You just need 5 times that.
Wait, so it'd be multiplied? So it would just be,
5 times 3.
yeah. Wait,
Yeah, but like when the radical 3 is like y is going to just keep on 3.
Yeah.
And it's just 5.
so it's just 15.
And then AC would equal 30.
No, dB is 10.
No, the whole thing.
dB.
It is 10. No, come on. So,
AC is 15.
whole diagonal. Oh, I'm looking at
Yeah.
the triangle. Because if this one is 15, then the whole thing would be 30. So AC would be 30. Because if we do, because if the short side is approximately 30, it would be so 10 equals 2 times so then you just
Yeah, when dB
that'd be
just
2
be
times
10.
a divided by 2, so that equals 5.
Right.
And then this one sort of like times radical 3 so one of the rays would be 5.
Okay, I'm going to get moving here so we can get to some sine, cosine, tangent problems. Hopefully you notice you created a 30, 60, 90 triangle somewhere. One of these four are, all four are 30, 60, 90. What's the 10 acting at? That's my first question to somebody today. What's the 10 acting as in the 30, 60, 90? Hypotenuse, shorter leg, or the longer leg? What's the 10 acting as here? Six, what's the 10 acting as?
That's the hypotenuse.
Yeah, that's the hypotenuse. So take a look. 10's the hypotenuse. So if I divide both sides by 2, the shorter leg will be 5. Remind me again, what angle is the shorter leg across from? 4 in a 30, 60, 90. Where's the shorter leg across from? The 30. So now this will be 5, and if the diagonals bisect each other, this will be 5. So diagonal BD is equal to 10. What's across from the 60 then? Longer leg equals shorter leg, 5 times radical 3. 5 radical 3, they bisect each other. 5 radical 3. Can we add those? Yeah, we can add them up because they have the same radical. So AC will be 10 radical 3. Okay, 10 radical 3. Any questions from you guys now? All right. Next up, sine, cosine, tangent. Again, I'll put these up on Classroom, these notes. You'll see if you've been on Classroom lately, but that yesterday's notes was up there as well. All right, sine. How do you find sine? 2. Sine's equal to? Cosine. 10. Good work, everybody. And finally, tangent. 2 again. Good work, everyone. Good work. So there's sine, cosine, tangent. If you need a little help remembering them, no need to memorize. Just be able to spell SOHCAHTOA, all right? Try that again. And one last reminder before we get into a couple problems. If finding an angle, what do we have to remember to do? At the very end of the problem, I don't want to cross multiply. What do I want to look at on my calculator if I need to find an angle and I'm using sine, cosine, or tangent? 1, George? Yeah, good. Inverse sine, inverse cosine, inverse tangent. And just a reminder, if for sine and cosine you're doing this and the numerator is bigger than the denominator, you did something wrong, you're going to get an error on your calculator. Okay, anytime you do second sine, for instance, 6 divided by 4, it's going to give you an error. Okay, that's not the problem's problem, that's a your problem. Okay, so go back and figure out what you did wrong. All right, let's look at a couple examples, and you got a group one. 2, right there underneath number 1. Length of a rectangle is 8 and the width is 6. So however you want to put 8 and 6, people, here's the length, here's the width. Find the nearest degree to measure an angle the diagonal makes with the longer side. So draw a diagonal in, and it won't matter which diagonal you draw in because diagonals are congruent in a rectangle, so it won't matter. Now let me draw it in. So make sure you know where your angle is with the longer side. So look where the diagonal and side 8 meet. Diagonal and side 8 meet. That is the angle you're trying to find. May look different in my diagram. Who cares? Just make sure you find the angle between the diagonal and 8. Okay, right angle, opposite sides congruent. All right, let's do this. Tell me what the 6 and the 8 are. Opposite, adjacent, hypotenuse. What's the 6 and the 8? Let's go, George. 6.
6 is opposite.
Adjacent.
8.
8. Yeah, thanks. You got me there. Got me. 16. If I have opposite and adjacent, which ratio do I want?
Tangent.
Tangent. All right, next person, set up the equation for me. Tangent of 5. Tangent of Whoa, I need an angle here, though. X equals, go ahead now. Opposite over adjacent, 6 over 8. Not cross multiplying. We just talked about that. Not cross multiplying. We're going to do inverse. Inverse tangent, 6 over 8. And remember, tangent is the only exception where numerator can be bigger than, I know it's not here, but the numerator can be bigger than the denominator in tangent. So everyone goes, second tangent. What are we looking? To the nearest degree when you're ready? 2? 37 degrees. Any issues? Calculator issues? We're all right? One more together, and then you got a group one. 8. Go to number 8 for me. All right, a lot going on here. I always love these type of questions. I'll tell you why here in a minute. So you got a man who is 5 feet 9 inches. All right, here we go. Can we have a real life discussion here? Reality check, common sense check. His shadow. You're outside, everybody, and you see your shadow. Where is it usually located? Or not, I even say usually. Where is it always located? On the ground. It is not beaming off your forehead. All right, you would probably be a freak of nature. All right, probably not be in this class or in this building. All right, shadows are on the ground. So let's put them on the ground and not beaming off your forehead. And he's standing perpendicular to the ground. Good, because we need a right angle here. What's the angle of elevation? Elevation, is that looking up or looking down? Elevation, anybody looking up or looking down? Looking up, yes, looking up, ground up. There is still another problem, though. What's our issue still? Romeo, what's your issue? Yeah, you can't, this is not 5.9, everybody. This is not 8.6. All right, so we need to convert it all to feet or all to inches right now. All right, because I can't leave both here hanging because I have no idea what I'm going to put in my equation. So you guys want to go feet or inches? All inches? All right, all inches it is. 5 feet, 9 inches, I believe. We got 69 inches. If I'm doing my math right. 5 times 12 plus 9. Ooh, 8 feet, 6 inches. This is over 100, huh? 12 times 8, 96 plus 6, 102. 102 inches. All right, there you go. So now use 69 and 102 instead. All right, so what are the 69 and 102 to the angle then? Oh, 3?
69 is the opposite.
Darn right.
102 is the adjacent.
Yep. So we're using which ratio in this problem? 17? Tangent. Nice. Set up the equation. You guys are just like machines. 9, you want to set up the equation?
Inverse tangent equals 69 divided by 102.
There we go. Inverse tangent. Hopefully we get one of those choices. No, we're in trouble. Nearest tenth of degree, what are we looking at? 3?
Uh,
Take your time.
the first.
Is that?
34.1.
There you go. Good. Ready to go beast mode in your group right now. Here we go. Number 6. Again, I'm assigning the challenging ones. See you, Molly. I'm only assigning the challenging ones in your group. So go ahead. Number 6. It's going to take a little bit of time. Be patient. Be patient. All right. What do you think? Going to try to put a couple, not a lot, maybe 2 or 3 of these challenging ones on the unit test next week. All right, so we're finding the distance from A to D. Problem is, if you look at side AD, that's not part of a right triangle, is it? Okay, so I can't use sine, cosine, tangent on triangle ADB. But I do see 2 other right triangles. I see the big one, ABC. So if I can find side AC and subtract that from the smaller right triangle BDC, DC here, everyone agrees I get AD. So that's my plan, using right triangles and sine, cosine, tangent. Find AC, find DC, subtract them, I'll get AD. So let's talk AC. What angle would I need to use, 7 or 16, to find AC? Use the triangle that has AC in it. Where's the angle, 7 or 16? 7. So I would need to do tangent, and I'll show you why, of 7 equals 125, because that's opposite it, over adjacent, which is AC. All good? DC can be done very, very similar, except now I can't use 7. I want to use what angle instead? 16. Tangent of 16. Still use 125 because it's opposite. Now finding DC. Cross multiply both sides here. Don't round your answers, right? Don't round them, don't round them, don't round them. Use the full calculator display, subtract the 2. AD here to the nearest foot. What do we end up with? What do we have? 582 feet. Anything else? We okay there? Now, I don't want to talk about it now, but there is a possibility you could probably use law of sines here too if you found all the angles in the diagram. But I'll talk about that after break. All good? One more before we call it a day. Any questions here? All right, another challenging one. Go ahead and go to number 19. Hey, so you don't have to read everything here because this is a long-winded problem about Joey and this thing called the winch. Here you go. Ready? Here's what you need here. It says find what's the approximate length of the entire cable. Hey, everybody. There's the cable right there. Find that entire length for me. That's what it's asking for. Okay? Find the entire length of the cable.
Wait.
Be careful. There's a little trick here. Be careful. All right, let's get back to this problem because I got 5 minutes here. Okay, so we had to find both sides here to add up the total for the length of the cable. So let me start with the hypotenuse, and the 14 is adjacent. So I'm going to find x, which is the hypotenuse first, using cosine. Cosine 42 equals adjacent 14 over, for me, hypotenuse x. You cross multiply, you end up with, let's see, 14 over cosine 42 in your calculator. Keep that whole decimal for me, right? Keep that whole decimal. Next, now I'm going to find y, but everyone see the issue. When you find y, you're actually finding this full side and not actual length of that cable on that side. So when I do sine of 42 equals y over, actually, no, I'm going to use tangent here because I'm going to use the 14. Tangent of 42 equals opposite y over adjacent 14. Take a look. Y is going to be equal to the tangent of 42 times 14, but what do I need to do at the end? Zach? Subtract 2 at the end. All right, so make sure we subtract 2. I add the 2 together. Final question here. How long was the cable? Making sure I subtracted 2. How long did we get for the cable? 14?
Oh, I got 29. Oh, for the whole thing.
Whole cable.
Okay, I got 29.5.
29. How's that look? 29.5? 0.4? One jab.
Well, it was 29.4445. So if you round to 5, then you round to the other 4.
No, where did you guys learn to round? You look at the first. You look at the second number, which is a 4.
Even I got that.
4 says keep the 4. We don't keep looking down the whole line there. All right, have a good break, guys. 2 days of review when you get back.